Hello all, welcome back to software engineering. We are entering into module 2 of intermediate DSA. We'll start with prefix sum, the concept of prefix sum. And agenda for this prefix sum module is to discuss what is prefix sum and uh, you know to see some of even and odd index elements and discuss some special problem on the special index. Okay. Let's quickly get into one question. Given n elements and q queries, for every query, calculate the sum of elements from L to R. Okay, so the example goes like this. You have given a you are given a array from index 0 to 9, so n elements of size n. Okay, and you are given q queries of size small q. Now for each query has two elements L and R, that is left and right. Okay, we have to find sum of elements from L to R. Let's say my L is 4, R is 8. So from index 4 to 8, the sum is my answer. So my first solution is, there are series of solutions. First solution is 5 plus 2, 2 plus 5 plus 2, 7, 7 plus 8, 15. 15 minus 9, 6. 6 plus 3, 9. Okay. Similarly, index 3 to 7. 4 plus 5 plus 2 plus 8 minus 9. Totally 10. Similarly, 1 to 3, which is 6 plus 6, 12. Similarly, 0 to 4, minus 3, 3. 3 plus 2, 5. 5 plus 5, 10, 14. And 7 to 7, which is only start and end index is 7, which is minus 9. So our objective is to find sum of elements from L to R. So there are two inputs, one is array and one is queries. So generally, how do we do? General brute force approach is for every query over here, okay, we can run a loop from L to R and accumulate the values in a variable sum, right? Let me quickly start writing solution for this. Right, let's start with the brute force approach. Okay, so I have q queries and n array elements. So void print sum. Okay, so my attributes are integer array, then size of the array, followed by the queries. We are seeing a two-dimensional array, so I am taking a two-dimensional queries. Then q is the size of the queries array, two-dimensional. So our intention is to find sum of elements from L to R for each query. So I'll start writing for loop, iterate over the each query. So int I equal to 0, I less than q, I plus plus. Right? L equal to, I want to take the left, I want to extract the left index, starting index. L equal to queries of I comma, I know as per our structure 0th element index is my L, right? So I'll quickly re-show the two-dimensional structure. Yeah, two-dimensional array where my 0th index is L, first index is R for each query, right? So R equal to queries of I comma 1. So this is my L and R. Okay, this is my L and R. Now I have to initialize a variable. I have to find sum for each L and R. So sum equal to 0. Now for loop j equal to L starting from L. Okay, j less than or equal to R. If it is L to R, already your R and L will lie between. So this is obvious, your L and R will lie in the size of n. It cannot be even equal to n, it will be less than n, because the final index can only be n minus 1. Okay, so I am not writing that check. I am considering j is starting from L and j is less than or equal to R and j plus plus. So now I am iterating from L to R on the array. So simply I will take sum less or equal to ARR of j. Right. Once I complete this for loop from L to R, I can directly print sum value. So this will be my sum value for each of the query. Okay, it's straightforward. I am iterating on Q, taking out L and R for each value of Q, and again I am iterating from L to R on the main array to find the sum and adding the sum, printing the sum here. So if we talk about the time complexity, it's evident there are two nested loops of iterations n into q, right? So, and space complexity, I am not using any extra space. I'm only using L and R and sum which are of constant space, so order of 1. Right? Can we still optimize this? This is any general brute force approach where we iterating through each query and finding the sum on the array. Right? Now let me give a real life example. Let's talk little about the cricket scorecard. Okay. Right. Generally, let's take an example of the sport cricket. Cricket scoreboard looks like this, right? From over 1 to 10, I am taking example from over 1 to 10. The score is a score how, for each over how the score is rising. Now, if I ask a question, what is the score in the 7th over itself? So this score is till 7 overs, and my question is, what is the score in the 7th over? Right? What simply we do? We'll simply do 7th over score is 7th over score, that is 65, minus score till 7 overs minus score till 6 overs. So that is the answer would be 16 runs, right? Only in 7th over. Similarly, if I ask what is the score from 6th to 10th over, 6th to 10th over, what will I do? I'll take 10 over square minus, will I do 6th over minus or 5th over minus? If I do minus of 6th over, I will lose this score as well. So what I have to do? I have to remove what is before 6th over. So that is minus 31, score till 5th over. So answer is 66 runs. Right. Now score in 10th over itself. Score till 10 overs minus score till 9 overs, which is 9 runs. So if you see, this is similar to whatever we are trying to solve. We have an array which is indexed and we have queries to find out from 6th to 10th or only in 7th over or only in 10th over. Right? So there is an L and R we are trying to solve. How did we solve? We were easy to solve because the score here is a pre-sum, prefix sum, or it's a cumulative array. It is not 65 is not the score in only the 7th over, it is a score till 7 overs, right? So the optimization would be is we need to store cumulative or prefix sum array to answer the queries in constant time. So we would need something like this scoreboard which will give you cumulative. So the concept would be, right, you have an array, right, you have an array. First try finding the prefix sum of it, prefix sum array, cumulative array of it. So how many elements you have in an array? 5 elements. So your prefix sum also has 5 elements. So first one is as usual same. Your second element should be in the prefix sum should be sum of 2 elements till here. So 2 plus 5 is 7, right? And third element is sum of 3 elements, 2 plus 5 minus 1, which is 6. Fourth element would be sum of elements till fourth, so that is 6 plus 7, 13, and finally this is 14. So if you see the observation, prefix sum of 0th element is equal to directly ARR of 0. Prefix sum of first element is equal to ARR of 0 plus ARR of 1. From the above recursive relation, can I write ARR of 0 also as prefix sum of 0 plus ARR of 1? Now, prefix sum of 2, second element would be generally from the above ARR of 0 plus ARR of 1 plus ARR of 2. 3 elements we'll add, right? This, what is this? ARR of 0 plus ARR of 1 is again my prefix of 1. So it is prefix of 1 plus ARR of 2. So in the recursive relation, can I write prefix sum of any ith index is equal to prefix sum of I minus 1 index if exist plus ARR of I, okay, where I is not equal to 0. If I equal to 0, we already know that PRR of 0 is PF of 0 is ARR of 0. So this is recursive relation to find the prefix sum. See, it is simple, it is very simple. Prefix sum of ith index is prefix sum till I minus 1 index plus ARR of I from the array. For 0th index, it's directly ARR of 0, right? We'll use the same concept to solve our question. So I have the array ready. First let's try finding out the prefix sum, okay, for the given array. So yeah, so my prefix sum would be, first is 3 as it is for 0th element, next is 3 minus 3 plus 6 is 3, 3 plus 2, so we directly take from here, 3 plus 2 is 5, 5 plus 4 is 9, 9 plus 5 is 14, 14 plus 2 is 16, 16 plus 8 is 24, 24 minus 9 is 15, 15 plus 3 is 18, 18 plus 1 is 9. Once I have the prefix sum, so what do I need? I need, so come on, it is similar to score from 8th over to 4th over. What we'll do? We'll take cumulative score in 8th over minus score till 4th over. If I remove 4th over, even 4th over score I will lose. Third over can be written as 4 minus 1, right? which is equal to, if you take what is P of 8, this is P of 8 from the question. 8th index is 18. What is my third index is 9, which is equal to 9. Right, we'll compare the answer later on. We already wrote it earlier. Now 7 to 3, prefix sum of just a second, prefix sum of 7 minus prefix sum of 3 minus 1, that is still second index. So prefix sum of 7 is 15 minus prefix sum of 2, it's 5. The answer would be 10. Similarly, prefix sum of 3 minus prefix sum of 1 minus 1, which is equal to 3 is around 9, minus of minus 3, which is equal to 12. Right. Next, prefix sum of 4 minus prefix sum of 4 minus 1. Sorry. 0 minus 1. So 0 minus 1, index of negative number, is it possible? No. What are we trying to solve? Starting from left is 0, ending at R. That means this is edge case, right? Which is you are asking till 0 to 4th. You can directly add it, right? So we have already calculated, that is prefix of 4, which is equal to 14. So where my L is equal to 0, that's an edge case. We will see how the concept will change, but L is equal to 0 is the edge case for us. And prefix of 7 minus prefix of 7 minus 1, which is 7 is 15, minus 1 is 24. This is equal to minus 9. So the sequence we got is 9, 10, 12, 14, minus 9. Let's just quickly compare this with whatever dry run we did earlier. 9, 10, 12, 14, minus 9. It's the same one, right? We solved using prefix sum. This is similar to your scoreboard. Whenever you get prefix sum question, just remember the scoreboard. Now generalized equation. How can I generalize this equation? Right? So L to R, which is what I am trying to find the value of it. So prefix sum of R minus prefix sum of L minus 1 before it, right? When my L is not equal to 0. Okay, if it is equal to 0, prefix sum of, right, directly take it R. This is when L is equal to 0. So my generalized equation is this one, to find the solution. This is final solution where you would need to compute the prefix sum first, then apply this to find your answer. So I hope this is clear. We'll quickly code the final solution for the given one. Okay. Void print sum int array int n 2D array of queries and int q. Okay. First and foremost, we have to define the prefix sum of n. So prefix sum array of 0 is equal to ARR of 0. This we discussed. Now ARR of 0. Now for I equal to I less than n I plus plus prefix sum of I is equal to prefix sum of I minus 1 plus ARR of I. So this is a logic to find the prefix sum, right? Once you have done this, you are already having the prefix sum array. Now it's only the matter of iterating over the queries. Now int I equal to 0, I less than q, size of the queries array, then I plus plus, okay, int L equal to queries of I comma 0, first element is my L, int R equal to queries of I comma second element is my R. Now it's straightforward. If L equal to 0, right, print prefix sum of R. That's it. Okay. Else L is not equal to 0. Print prefix sum of R minus prefix sum of L minus 1. Okay, done. Now let's see the time complexity of this. Okay, time complexity. So if you see, finding prefix sum is order of n. And here if you see, after having the prefix sum, I am only going through q iterations to fetch the value. So I am directly accessing, this is a constant time in array. So my time complexity is order of n plus q. Earlier when we used brute force approach, the time complexity was order of q into n. Now we beautifully turned it into order of q plus n. And what is the space complexity? Did I use any extra space, extra memory apart from input and output? Yes. My prefix sum array is an intermediate array which is serving our purpose of, this is of size n. So my space complexity is n. Due to prefix sum intermediate array, this space complexity now is n. So I'm okay to space complexity of order of n, where my time complexity is drastically reduced from q into n, order of q into n, to order of q plus n. Okay. In next class we'll discuss about we'll discuss one question on the same. I'll give it as an you can try this out. Okay. Same, you have an array of size n, queries of size q, okay, which starts with s and end, start and end. Similarly L and R we say here s and e. Now your task is to return the sum of all the even indexed elements from S to E. Quick example: 2, 3, 1, 6, 4, 5. Okay, and S and E's in the queries are 1, 3, 2, 5, 0, 4, 3, 3. Okay, so we'll solve for first query, index 1 to 3. So this is index 1 2 3. From index 1 to 3, how many even index are there? Only one. So sum of even index values is 1. From 2 to 5, 0 1 2 3 4 5. So it's 2 to 5. Next query, how many even index values are there? One is index 2 plus index 4, which the answer is 5. So now it's not every index from S to E that you have to add, only the even indexes. Okay, so this is a question, try it out, and we'll meet in the next lecture. Thank you for listening. Software engineering.